Welcome to this exercise on solving exponential equations. Exponential equations, that's an equation like this one here, where the x is part of an exponential function or is just in the exponent of some term. So to get there, we have to cancel out this exponential term in one way or another. And how we go about this, we're going to see on the next slide. However, before I get there, I can simplify this a little bit by getting rid of this fraction on the right by multiplying with the denominator which I have here. Then, since this part here is the same as the denominator, I get this exponential function of 1 plus x squared, and on the right side I will just have the denominator 1 left. Well, since I want to get to the x, I first have to get rid of this square term, so of the exponent of 2. To get this done, I can just take the square root on both sides of the equation. So on the left side, it gets rid of the squared. On the right side, I have two possible solutions. I have 1 or minus 1 as a solution. However, well, in both cases, I want to get to this x inside the exponential function. So first I have to get rid of this exponential function of part. And this I can do by applying the inverse function to the exponential function, which is the natural logarithm. And I do apply it to both sides of the equation. Well, here for the first one, it will not be a problem because I can apply the natural logarithm to 1. Result will be 0. But here for the second one, well, I cannot take a logarithm of negative numbers, not at least if I work with real numbers. So this second possible part solution does not actually work out, so I cannot compute here any solutions, so I can omit this part and only continue with the first possible outcome of taking the square root up here. So apply to the first one the natural logarithm on the left, on the right. As I said, this one will turn out to be 0, and here, well, I applied the natural logarithm as an inverse of the exponential function so that both of them will cancel each other out. So I'm just left with this equation, 1 plus x, the inside part on the left, and 0 on the right. And well, then to get to the x, I simply have to just go with minus 1, giving me the one solution to this equation, which is minus 1. Well, that's then everything there is, because for exponential functions, I can insert any value I like, so I do not have to check whether this is a feasible solution or not. Well, so far so good. So this brings me to the end. I say goodbye and see you next time.